morning, everyone. I'm glad to be here. I think Sanjay stole my line. I wanted to be saying that I'm honored to be here at the CDNLive event. And I thought that more than being honored, more important is to be between friends. And I think with Cadence, we have had a longer and joyful relationships in the last few years. We developed a lot of products and ideas together. Before I enter into the presentation for autonomous, a few words about me. I've been working, as I said, 17 years in this company, Motorola Freescale NXP, especially starting up businesses, the chassis business, the radar business, the vision business, the ADAS business. And now they asked me to engage into this autonomous driving adventure, which is very fascinating. And while I was watching Tom, excellent presentation, great job, I noticed how lots of the names that Cadence uses are sounding like Latin. My mother is a Latin teacher. She can speak it, like the Pope. I think she and the Pope can have conversations. And I thought I made my unconventional association here in Munich. Latins are associated to dark beer, to strong beer. So maybe I thought it's a good way to have new ideas, put together the good beers of Munich and the great platforms of Cadence. I don't know, maybe something will come out in the futures that will bring us into this new world. So let's talk about autonomous driving, roughly half an hour for you to enjoy. What we're going to talk about is, I'll try to share with you a little bit of my thoughts about what is autonomous driving, how I see it, why is it important for us, the architectures that comes along with that for future autonomous driving, AD. What is the key part of my engagement in this is to find a way to replace the driver in an intelligent way as much as possible. And I'd like to touch a little bit on what I think that Cadence, together with all of us that contributes in this market, can do in terms of accelerating the path toward autonomous driving. And finally, we will have a little bit of a conclusion, and you will understand why I like the aesthetic of engineering during the conclusion part. So let's get going. Let's start with the why. So let's start with the high level, what drives at high level the autonomous driving. Three things I believe personally, are important at this stage for our progress into a future mobility. We need to, of course, make sure that we are going to be reducing pollutions. Cars still consume and pollute the air. We have to be greener. This is important for all of us. We want to enjoy the experience. It's very interesting. It is a driving experience that this new mobility will bring to us. But most of all, we have to save life. This is really what drives my personal why. It has to do with taking care that no more fatalities happen. We don't leave people on the ground because of accidents. And as much as possible, no accident needs to be caused by the machine itself. So this is really the reason that drives most or many of us and should be at the fundamental point as we think of autonomous driving. Driving experience with no accidents and greener. So we look into the future, and everybody knows the famous levels, right? It is definitely a revolution. I think of this as a revolution in all sense. We're going to go from today's autonomous, ADAS, if you want, more than autonomous, into a full autonomous, which means, in the real semantic of the words, that the machine will take decision on behalf of the passengers, on behalf of the owners of the vehicle. And step by step, there will be less driver intervention until we'll see no driver intervention at all. And the questions that I'm asked is always if it's going to happen, when it's going to happen, or how is it going to happen. I don't think so. This is not the questions to ask. I think the question is how fast and how we will be accepted. As I said before, it is a driving experience that is going to change. It's like the mobile phone a few years ago that completely revolutionized our way of being connected. A mobile phone is coming into a mobility invention. So we're going to have to live this experience, we're going to have to live this transformation, being open to new experiences. And how fast is the biggest question. It's not only a legislation problem, as you will see. So what do we seek? We are all users of the vehicles. Tom said he likes to drive the car. I do a little bit less, but I like to enjoy being taken by the car sometimes. And therefore, the comfort is very important for me, right? Being there, knowing that it will take care. The safety aspect, as we said. Efficiency, and it's not only being greener, it's efficiency in all the dimensions of the vehicles, in the connectivity, in the capability to solve problems at a certain stage when you are in traffic, when you're not. And of course, we want to have an easier mobility. Eventually, you all know that the reason why we love the vehicles and the cars is that because it's a strong sign of independence. We can go with that wherever we want, whenever we want. We don't have to depend on the famous airplane or airport, let's say, experiences. So it's very important that we understand what we want from it. At the same time, the challenges are not only technical. When I look at the challenges for autonomous driving, I first of all think of the legislation problems and the harmonizations. It's definitely different to be on a highway in Germany, on a highway in the United States, and on the new highway that goes from Noida to the Taj Mahal, right, Agra. It's not also a beautiful highway, but you might have experience of incoming traffic against you. And this is essentially a problem. So we have to be aware that there will be different situations in different places of the world and different legislations as well. So it's going to take some time. I think it's going to be faster than we thought only 3-4 years ago, especially in the legislation sense. The second part of the not only technical challenge is that technology changes lifestyles. So it is very interesting to understand the psychological aspect of being in a self-driving vehicle. How does it feel, right? When I tried the first time, it felt really strange, right? You have this steering wheel that you still have to keep your hands on it for legal reason, even if you don't steer, and you feel that you are taken somewhere. But after like the first 15 minutes that you are hyper conscious of the problem, everything becomes very natural. I think our children will not even notice the difference. For them, it will be natural to be sitting in a vehicle that takes them at school or wherever they have to go. And the last part, which is the one that I sometimes think most of it, is trust and dependability. We got to trust the machine, right? I'm not going to enter into the philosophical discussion if a machine has a consciousness or not, but trusting is an important aspect of how we live these new inventions, and we have to be sure that we can depend on them. Dependability has a big aspect, not only from a psychological point of view, but also from a technical and an engineering point of view. It's practically the sum of all our availability, safety, reliability concept. It all makes the dependability part. So at a high level, when I work with the team in Munich, here with the architects, we think of autonomous driving as split in two macro domains: the situational awareness or assessment part. In artificial intelligence, this is called modeling, right? And the behavioral policy and actuation part, which the artificial intelligence world will call planning. So there is a lot of things that got to be made and taken care of. We have to think about the sensors that we're going to use and the actuators on the other side. We need to think about the fusion architectures when we put together the sensor data and the level of complexity that that brings. We're going to talk about that later. There is a problem in bringing interoperability between the different pieces that contributes in making this autonomous driving, and that are very much heterogeneous, very much different among them. At the same time, decision frameworks and algorithms, huge investment from many companies into algorithmic knowledge, AI, so-called. Safety and security, not to be underestimated, especially the safety aspect, but also the security, because if you invest so much, you need to secure that investment. And the scalability and modularity of the application. So all of these are dimensions of the problem that eventually comes down to what companies like Cadence have to solve together with companies like NXP and the rest of your partners. So let's look now a little bit into the architectures or high-level description. So I'm not going to go into technical details, but I'll try to give you an idea of what will be the major architectures that could be, the major building blocks of the architecture that could be using in autonomous driving. Essentially, as I said before, with using an artificial intelligence language, I talked about modeling and planning, but for the consumption of the general audience, in NXP, we use the terminology of sense, think, and act. And these are the three major macro domains that needs to be covered in order to achieve a full autonomous driving architecture. And in order to do that, we have to leverage a massive ecosystems capabilities, because I don't think any company alone can do it, even if verticalization or the vertical approach is quite evident in some of big OEMs right now. But the necessity to share knowledge is key and very high. And this will happen faster than I think everyone can think of. So there is a lot of trends into this cooperations, into this merging of know-hows, into even acquisition in a certain sense, as you know very well. Because we have to get to the point where the processing, the security, the safety will have to be put together in one big platform for this type of applications. So let's look at the domains. In NXP, we decided that 5 are the key domains that are eventually connected by a strong gateway capabilities. We need to have a connectivity domains, so we have to be able to talk eventually between vehicles. We have to have a driver replacement domain, which is substantially the capability to drive the vehicles without the driver being in charge. We have traditional domains like the powertrain and the vehicle dynamic safety domains, body and comfort. You still have to open doors, close doors, you have to move windows and so on. And then there is the driver experience domain, which is also very important, especially in level 3, where you have to give back to the driver the control of the vehicle in determined moments. And from an NXP point of view, we think we are quite well positioned in many of these domains, essentially because we can cover from connectivity. The NXP company is very strong on secure connectivity, in driving replacement with a lot of products, some of which strongly influenced by the Cadence IPs for the ADAS part specifically, right? In radar, for example. Powertrains, a classic from the former Freescaler part of NXP, same as body and driving experience. So a very strong company that is very broad in automotive, which is also going to look even better in a few months from now after this procedural will be finished and the merge with Qualcomm will happen. So we look forward to be together with this new owner, as we will have a much stronger and complete solution for faster time to market and full scalability, as Qualcomm brings strong presence in the central computing capability for fusions, in infotainment, in cellular connectivity, as they are a strong mobile IP providers, and in connectivity. So overall, an architecture for engineering, for development that is very strong, is complete, and with which we can definitely serve the market together with you guys in developing new architecture and new innovating products for the autonomous driving. So let's talk about now a little bit more about the driver replacement. What does it mean to us to replace a driver? So the driver replacement starts with the modeling part. So the modeling part has to do with the assessment, the situational assessment, so understanding what's around us. And we see 3 major sensors that will drive these capabilities, plus 2 that you will see other key dimensions. Among the 3 sensors, radar, camera, and LiDAR, the companies works a lot on all of them, especially on the radar, which I think is going to be the biggest surprise, most underestimated, but strongest sensor possible, I think, in my personal view, because it works in almost under all circumstances, in every environment, and it can be miniaturized and become very cost-effective. Interesting things with radar, we can do almost everything. The only things I think we cannot do is see colors, but maybe one day we will be able to do that. And it does help a lot in improving the perception. So what we are working hard in our companies, especially with your help, as you have been working a lot with the Tensilica IPs on our radar success, we're working hard to make radars the co-primary sensor together with cameras, of course, because we believe that cameras and radar associated together will be at the fundamentals of any level 2, 3, 4, 5 for autonomous driving. Camera is, of course, the vision sensor is very important. All the infrastructure for driving are made for humans, and humans' highest bandwidth sensor is our eyes. So essentially, we have to be able to see. This is the semantic aware sensor, so we know how to read, we know how to interpret, and cameras will remain very important, especially the front vision camera. They see colors, very important, and is the most advanced, as I said, human sense. So it's fundamental to have it, it's fundamental to continue to develop around that. It's a very strong artificial intelligence know-how base is attached to cameras. We need to know how to interpret, how to abstract features, how to understand it. And of course, it has a little bit of a limitation at night, even if by now with the near-infrared cameras, almost everything is almost visible, also at very low light level. And LiDAR is an interesting sensor. It allows us to map very accurately objects around the vehicle. It's becoming much more integrated, and Tom said it. It's a new reality. We do like it as a sensor, even if we don't develop the sensing part ourselves, because the computational part attached to it is very intense, and we are very good at that. So from that point of view, we'll continue to invest in that. So these three are the fundamentals. And the other two things that we think are important as well are the communication aspect. Again, an area where the cooperation NXP and Cadence has been very fruitful in the last few years. And the mapping part. So communication, because we like to talk, especially Italian people like me, likes to talk a lot. And the maps and localizations, because without knowing where you are, you don't know where you want to go. And in that sense, watch out what radar will be able to do in the next few years, being the complementing part of cameras for mapping. That will be a very interesting part, I think the most underestimated part of this future. All of this, of course, requires data management, requires connectivity, requires high bandwidth, requires all this type of communication, and this requires IPs that you guys are developing very interestingly. Also, I will say I was very interested in the packaging story, because we can put together a communication part and a data processing part in the same module, maybe in the same package in the future. This is another path that we are also definitely looking into that. So having said that, after the modeling, we have to do the planning. Planning is the most fascinating part of the problem because it's not solved. I would say that the modeling is quite understood what can be done, both in traditional and not traditional, let's say, techniques. But in the planning, how do you engage with other players is not yet understood completely. One thing that is very interesting is that artificial intelligence had 3 winters, right? I don't know if you know the story, right? The first winters was in the 50s. I think it was in the United States was trying to find ways during the Cold War to automatically translate Russian messages. And they invented this beautiful mechanism by which they could read or translate automatically the Russian messages until one example was brought up, which was, I think, from the gospel. I think the spirit is willing and the flesh is weak, which was translated into Russian and back into English as the vodka is strong and the meat is rotten. And they realized that trying to do that was not, even if correct, it was not semantically very correct. And that was the first failure, right? The second failure was in the 60s, where, again, in the United States, they tried to put some therapeutical conversation, machine that could talk to people using neuro-linguistic programming and try to find a way to maybe take them away from the stress of working on AI maybe. And they realized that it was very easy for human being to catch the machine into a catch-22 situation, right? So the machine will always, like on Siri today, you can do that if you try, get answering with the same question, which was going nowhere. And then the expert system of the 80s also didn't make it. I have thought about it, why we had 3 winters and now we're going to have a long summer. Is that going to happen? I think so. And the reason is because we realized that a machine, a car, does not have to drive like a human. So the fundamental difference here is that as deep learning came into being visible, let's say, not to life, but at least being visible in October 2012, another October revolution, if you know what I mean, what happened is that they realized that we should not imitate humans. We should really let the data tell the story and see what the machine comes out of that. That is a fantastic realization that you don't have to imitate humans because humans don't have 6 eyes. We don't have radar incorporated in our bodies, and machine has. At the same time, it represents the most difficult part of it because when we don't know how the machine works, we cannot be fundamentally sure of what they're going to do, and liability is a problem there, right? So from this point of view, we think that the problem will be to put together the two art of policy of driving behaviors findings, the two art which are the supercomputing capability. We have competitors that are extremely good at that, together with the safety knowledge. And the safety knowledge comes through semantic knowledge, comes through understanding, through engineering. This is, again, a point where Cadence can be of fundamental help, because the IP that accelerate with engineering knowledge into it will represent the point that you can control and understand within the artificial intelligence frame. And this is why we will be able to bring the autonomous vehicle into the place in the long term. So it's for us is the combination of two realities, the supercomputing and the safety. And the safe computing, one is data-driven, the other one is engineering-driven, and only by balancing these two, we will be able to really avoid the fourth winter and prolong this summer, which is ongoing now for a few years, right? And I promised that I was going to talk about the fusion topologies. I'm using a classification which comes from the director of laboratories in the United States Defense Lab in 1999, I think, was when they invented. We always hear about the problem of centralized versus distributed. The definition says that distributed has no central unit and centralized, everything is in the center. Both of them can theoretically exist. Actually, there are systems that use one or the other, especially in weapon systems. But it's interesting that I believe that in the end it's going to be an hybrid model. Again, for the reason that I just explained, to put everything in the center is computationally very difficult. It tends to explode. It's more than linear, the computational explosions. To distribute requires a perfect communication, and we know that perfect communication is also not always happening. To now layers the knowledge in successive layers and having smart sensor together, like radar and camera, smart sensor, together with central processing, I think is the best solution. It's the solution that guarantees us to also control the longer term path for this market. So NXP is bidding on the hybrid model. We're building both. And I actually have to say the market is bidding longer term on the hybrid model as well, right? You are putting the engineering knowledge together with the data-driven capabilities. So let's talk a little bit about the accelerators. I think this is an interesting part of the talk. It's the one that comes closer to what Cadence is doing and to the capabilities and innovations that you guys have. So first of all, why do we need acceleration? Essentially, artificial intelligence, which is the science of machine taking decision autonomously, so without being told, needs machine learning. Artificial intelligence is bases itself, let's say, on machine learning, on the capability of machines to learn. And machine learning is, especially for automated driving, or autonomous, much better than automated, is a big data problem. And when you have big data, you have to have computational acceleration. You cannot use the control flow. You have to use the data flow approach, right? So this is essential. This is the fundamental starting point. And from our point of view, from my personal point of view, we need dedicated accelerators that are able to manage extra large data. You can think about it simply, the sensor in your vehicles are going to explode. Essentially, the number of data they're going to bring to you. I remember 2 years ago talking to big OEMs telling me, well, 1 megapixel is okay. Today, there are 8 megapixels. So in a few years, but really, literally, in 1 or 2 years, the number of pixels has just decuplicated. The execution parallelism is very important. We need to be able to parallelize, to do in parallel, because this is exactly what makes the machine eventually superior in the longer term of the human brain. They are not yet there, I have to say. And of course, the power efficiency, this is where us as a driver are still much better than machines, right? Our brain, 20 watt, 40 watt maximum, a machine is already 400. So there is still a ratio of 10x that needs to be reduced. But all of this just to say that we have to abandon traditional automotive approaches. We are not anymore control flow. We are data flow oriented. And that requires a complete different acceleration, enablement, software, and way of thinking. So from my point of view, the solutions in reality are already visible. They are coming, they are emerging, right? There is always one CPU, there's always one little controlling part, because eventually you have to start and stop the car. Eventually you want to have a way to control that it doesn't get out of bounds. But then there is a mix of potentials. We can talk about GPUs, we can talk about FPGAs, we can talk about DSPs. We have machine learning specific process like ASSP, and each one of these type of IPs have some pros and cons. GPUs are fantastic, highly parallel. They are I call them the king of a deep neural net. They consume a lot of power. They tend to be very heavy on that and maybe inefficient in certain circumstances. FPGAs open up the futures. So if you put an IP into an FPGAs, you can try new things. You can be flexible at the beginning. DSPs, very interesting, especially the one that Cadence produces, are very efficient. They create also an ecosystem that becomes important for the customers because you help them going faster in the market. Sometimes they are complex. You need to help the customer. The enablement is very fundamental there. And then there is machine learning specific things, like you can have a very efficient CNN IP. You do some of this in your portfolio. And they're non-standard sometimes. You have to really tailor that into what you want to do it. From my point of view, from our point of view, as we look into the industry, we love to talk about deep learning, but we know that 80% of the problem are still going to be linearized because eventually some engineering happens and engineers like to think in simpler form. So the first things that we are trying to do is make sure that everything which is linear algebra is perfectly done very efficiently in our computation. And then we add the nonlinear functions, which are essentially done through deep learning capabilities, neural net. This is why neural net are so much interesting. They are the best way to approximate nonlinear situation, which is reality today. So we need to understand how much neural net we want to put into a vehicle because it tends also to become very expensive in terms of silicon area, in terms of implementation. We have to understand how to optimize that part and the accuracy that are needed. So this is an interesting topic. I will not dwell too much into that because it will take another hours of presentations. But I'm sure that as a company that wants to invest in neural net, you're also thinking about how to optimize these areas. And there are other variables that are to be considered. Programming is. I think ease of use is the most important, in my personal view, characteristics for an accelerators. It has to come out with a total solution that allows the user to use it immediately. And I'll tell you, it's very rare. I have not seen a very good solution yet in the market. There's a lot of work that we need to do that you can help us also doing with us in integrating your tools, your capability into ours, and bring this into the next level, into the tiers of the OEM. Computational performance, it's a battlefield. Everybody likes to talk about their tera-ops. I think everyone can do it eventually because you can put transistor after transistor. You can get to the point where you have enough of them. But power is the largest mispromises. In the end, the car works on gas, right? And we know that when we pay that. And essentially, we have to keep this contained. Right now, for autonomous driving, it's not the top priority, but it will come, and you will see what happens when it will come. Architecture will change dramatically, right? And it will come very fast because we need to put this car on the road in the next 10 years. And then we have safety and security. I normally explain safety by saying it has to do with life and security has to do with money because you have to secure investment. It's very, very simple. If you don't make your system safe, you cannot take your hands off the wheel. And this is the fundamental of autonomous driving. Take your hands off the wheel. So safety is the most important one. Security comes immediately after because all this investment needs to be protected. You do not want to have hackers that comes into it and destroy your system. So it's a very interesting innovation path, also the security one. Throughput and latency to be connected with computational performance, of course, is often achieved, but is another problem. Connectivity, how do we move data? And the data bandwidth in itself, right? We always think we have done our job, we have given the whatever, bandwidth, gigabit per second or so many, and 2 minutes later we are told it's not enough, right? It's not enough because we all love to use more, right? And we all need to have more in order to innovate. So at this point, in NXP, we are making large investment. We are investing in our own research. So we are creating also the NXP net. Everybody likes to have a net, the Squeeze net, the Tech net, the Google net. We also have an NXP net. Like, sooner or later, we'll show it to the world. And it's fun because it is a way also to test our own capability to think differently. We have developed a lot of general purpose DSPs, some we internally, some we are using your parts because we find them very fit for purpose of what we're doing. We have developed also machine learning accelerator, sometimes by acquisition, I have to say, but into companies. And sometimes we just do it internally because we think that there is value in developing that capability as well. And we have developed entire platforms for infotainment, for example, in i.MX. And one of the future goals of our company is for sure is to develop the platform for autonomous driving, in which we definitely want to see Cadence be a big actor in that. So let's talk about my final conclusion, or what I think is important to keep in mind as we walk into the next 3-4 years of autonomous driving development. First of all, everybody's talking about it. Everyone talks about autonomous driving. It's true, it's a great and interesting topics. It's easy to talk about it. I think sometimes we have to be humble, right? Everybody throws out ideas, resources, and claim of success. It's difficult to be successful the first time right, and everybody knows it. So we have to be humble because we have to bring a solid products, a safe products to the industry, which will have to stay for a long, long time. It's at the hype level. The Gartner graph shows it. We are right at the top, and you see what happens after the top. This is a normal industry situations, and when I explain this to my senior executive presidents, I always tell them, we need to invent the Tibetan bridge that goes from the hype into the plateau, because if we go too deep, it's going to be hard, especially in terms of investment. It's going to be very hard. So we have to be pragmatic in where to invest the money and how to use them to accelerate this type of application. And let's not forget that everybody loves to talk about level 4, but what we need right now is level 2+, so the steering and braking autonomy, and the level 3. That will make a lot of interesting application even before we get completely off the attention while driving. Autonomous driving is valued, but needs investment. This is like the Mona Lisa, right? It's very much value, but you need to take care of her, otherwise it can get stolen, right? And semiconductor values doubles regularly. It gives us more input, it gives us more value, we can get more profit, let's say, but we cannot stop investing. And I have to say, the investment is quite interesting, investment perspective from the traditional versus the new entrant. The new entrants are very aggressive into that. And this is creating a dynamics which is very nice to watch in the industry, because you see the OEMs watching each other and says, what are we going to do about it? Trying to go into merge and acquisition, try to do new type of business model. This is a very interesting time to explore different type of approaches. And I have, even before talked to Thomas, says there will be many self-proclaimed winners. I don't want to sound too negative, but there will be also a company that has to ride this off. It's not going to be easy to sustain this investment. It takes a lot of perseverance and a lot of focus to keep investing into a market that will develop, but it's not there at the door. It takes still a few years before it becomes solid and stable. And still today, there is no OEMs that has a level 4 or level 5 on the road, because it's legally still not possible. So very demanding investment to be sustained in time. This is the key to continue. And the challenges, this is Lau Conte. This is the guys who told the Trojan not to bring the horse inside the city, and it didn't finish well for him. So we need to be careful and not get into his problems. So the access and control of large amount of data is key. So I'm saying that because I believe it. It's a big data problems, and having access to that and creating the fundamental possibility for many companies, for multiple companies to get access to data is important as well. It's not only one big company that can get all the data. There is a stronger relevance for safety and security. My personal view is that we will see safety being integrated more and more, not just the companion SoC. It's going to be part of the major computing unit. And we have a problem of speed of development. It's not anymore 7 years, like Tom said. it's less than 2 years and you have to redo it again. And you know how long it takes to validate an automotive platform. It's definitely more than 2 years. So we have to find methodologies in design, in packaging, that allows us to prolong the silicon node while we build alternative systems by packaging, by 3D expansion like Tom described. It's very, very true on that. Ease of use and deployment. If we are not able to understand immediately how a new platform, a new IP is used, abandon that immediately. Don't go into that type of deep dive. Focus on what is immediately clear, because that is the path for the fastest success. And we have to be watching the debate between the open standards and the proprietary tools, right? Open standards is what we believe. NXP strongly believe that the only way to enable this industry is to work on open standards, OpenVX, OpenCL, OpenMP, you choose it. Open standards allows dynamics that are strong in the industry. It's not one language, it's multiple languages that are interoperable and relocatable, right? And of course, the pressing debate between raw and object data fusion. If you want to talk to me about it later, I'll be glad to talk about it. I think, as I said before, in the hybrid model, we will have both. You have to be able to materially work on object, because this is the way it works today, but you have to give access to raw data, because specific problems can be solved better by having access to the raw data. And this is probably a way also to give new company potential to emerge strong with their ideas. And the winner, and this is David, that beat the big Goliath, right? And the winner is the company, or will be the company, that is able to master all the integration complexity. So autonomous driving is an integration problem. It's the problem of putting together so many different dimension specialities of engineering and psychology and legal problems, that the company that is able to bring this all together, or the companies, the groups of companies that can do it, will definitely emerge. And I expect new companies, not only the traditional ones, to emerge in this area. I think it's going to happen through partnerships, merger and acquisition. So it's going to be a big, continuous movement in the next few years of company buying company, creating partnerships. We have seen this year a few already, very important ones. And it will fundamentally be based on artificial intelligence. There's no way. It's an autonomous machine, so it needs to use artificial intelligence by definitions. Manufacturing flexibility, what I mean is the capability to use all the potential levers. Today we spoke about packaging, very interesting one. Others are possible, integration of memories and other type of integration capabilities. So manufacturing meaning possibility to put things together. RF CMOS in radar, just to give another example of a great technology that we have in NXP. And as I said before, we need to sustain the investment. And when I say we, I speak of the industry, I speak of the larger components, the governments, and in general, everyone that is interested in creating a safer mobility system. The last things, which is not the least and nor the least important, is the software approach. Ease of use is important. The model that comes with that is also very important. How are we going to engage such that the industry such that we can have the largest amount of contribution from a software point of view? And software is not just the writing, it's really the innovation part of it, like an Apple store in a certain sense. How can we have that type of platform that brings new application inside autonomous driving? With this, I want to thank the audience. Again, great pleasure for being here today. Thanks, Tom and Sanjay, for the opportunity, and look forward to talk to you. Thanks so much.